So we're going to move on into chapter 5. Now we're skipping chapter 4, and we're not really sure if we're going to visit that sometime this year or not. We might not. Anyway, let me see if I can try to get this thing to skip. So this opener, it's actually very simple. I just wanted to point something out to you that you could, watch this. So AS is congruent to ST if point is a midpoint, then divides segment into two congruent segments. And we were told that WA is congruent to WT, and then you have this reflexive piece. You could actually do this proof in just 4 steps. Now it's super simple, of course. The reason why I wanted to talk about it was we didn't end up using this information. And occasionally you'll have that happen. I think in this problem, it was actually a mistake that whoever originally came up with this problem probably either forgot that the reflexive was possible and you could do it with SSS, or didn't mean to include that at the given. But there are some rare cases where you may not use a given piece of information, but 98% of the time you're going to use all the given information. And actually, something to think about, like if you get stuck on a proof, okay, one thing to take into mind is to go back to the given and make sure that you have used everything that you were told. Sometimes you've neglected to use something, and that could be the key piece of information. Okay. Now, what we're going to do today in chapter 5 is we're going to move on. We've noticed in proofs that a lot of times we finish with congruent triangles. But usually we don't finish with congruent triangles. Usually we prove triangles congruent and then take additional information from those triangles, okay? We don't stop with the triangles. So for example, in the opening problem that we just did, it said in the problem above, what if we wanted to prove that AWS, this little angle up here, is congruent to angle TWS, the little angle up there? Of course, if the triangles are congruent, we know that all the corresponding parts are congruent as well, right? So, of course, those angles would be congruent. And that's what CPCTC stands for, okay? What this is what it means is corresponding parts of congruent triangles are congruent. Now, you can go ahead and just write CPCTC, but you need to make sure that you understand what it means. Corresponding parts of congruent triangles are congruent. And usually that's what we're going to be finishing. Well, we're going to be doing this in most problems. So let's take a look here. 2 congruent to 3, 4 congruent to 5. We have to prove. Now, I'm hoping you're thinking, we got to prove these triangles congruent. So I'm going to say angle 3 congruent to angle 1. Vertical angles are congruent. And then I'm going to say angle 1 congruent to angle 2, right? Because if angles congruent to the same angle, then congruent. And of course, we have a reflexive step in here. Now remember, what's going to be different now is you got to make sure that you match up these triangles correctly, because the last step isn't triangles. The last step is often going to be CPCTC. So we just have to make sure, again, it doesn't matter how I name the original triangle. So if I say triangle SVR, that is okay, as long as I match it up the same way down below, TVR, and that, of course, would be ASA. And then RS would be congruent to RT, CP/CTC. So no big deal, right? So now, corresponding parts of congruent triangles are congruent. Now this next problem, I apologize for doing this, for using the same diagram. 4 congruent to 5, RS congruent to RT. If you want to stop and do this on your own, I'll tell you it's a 6-step proof, okay? But anyway, I'll go ahead and do this right now. I'm going to say VR is congruent to VR, and that is, of course, reflexive. Now, we actually have triangles right away then in step 3, right? Triangle SVR congruent to triangle TVR, and that's by SAS. But we still have some work to do here. We're going to say angle 1 congruent to angle 2. So CP/CTC is not the last step. Actually, there's a couple things we still have to do. Now, if 1 is congruent to 2, remember, we can also say in step 5 that 1 is congruent to 3. Vertical angles congruent. And lastly, angle 2 congruent to angle 3. If angles congruent to same angle, then congruent. This again is called the transitive property. Okay. Okay, now on the back, this gets a little bit more interesting. You gotta be careful. There's a lot of information here. Angle 1 congruent. So, I'm gonna mark angle 1 congruent to angle 2. Disappearing ink. Let's see if we can get this to work again. So we have 1 congruent to 2, 3 congruent to 4. But then I have 2 congruent to 3. So 2 is congruent to 3, so these angles here are congruent. So I find it really tempting right away, and I think it's the way to go. Say angle 1 is congruent to angle 4, because this would be what? If angles congruent to congruent angles, then congruent. So there's some different ways of doing this proof. But we just said that 1's congruent to 4. Now remember, 2 is congruent to 3. You see, we were told that. 2 is congruent to 3 and 1's congruent to 4. So this whole angle, we can get this whole angle congruent to this whole angle by addition, right? And, there's different ways of doing this, but I think we can do this by proving these overlapping triangles. So watch, we can say that angle ADC is congruent to angle BCD if congruent angles added to congruent angles, then sums are congruent. Okay. So I got this whole angle congruent to that whole angle. I got this reflexive piece. You see, I can prove these two overlapping triangles congruent. Because remember, I said 2 is congruent to 3, these little sliver angles. So I got triangle CDA congruent to triangle DCB by ASA. And then we're going to finish up with CP/CTC dB is congruent to AC. Notice how with the method that we used here, I did not use this given information here. All right. But you could use that given information if you do the problem a different way. All right. So you'll see going forward is a lot of times a lot of proofs can be done using different methods. You could prove these two little triangles congruent. Okay, so if you want to explore, you could explore by getting these two little triangles congruent, which would then allow you to get EB and EA congruent, and then you add it to those two pieces to get the whole thing. I think it's about just as long, actually. So there is another way to do that one for sure. Okay, a new theorem today. It's not earth-shattering. All radii of a circle are congruent. I think you guys knew that before. It's not like you're going to have to spend a lot of time measuring that, memorizing that. Now remember here, when you see that symbol, like circle Y, that means that Y is the center, okay? Y is the center. We have AYU, this whole angle congruent to BYP. Again, when I see overlapping angles, the first thing I think about is potentially using subtraction, okay? That's what I think about. Now, I'm also told that I have a midpoint. So I want to catch up to my tick marks. I don't want to forget that midpoint thing. So I'm going to say AY is congruent to YP. And this would be what? If point midpoint, then divide segment into two congruent segments. And then I'm going to do my subtract. I'm going to say angle BYA is congruent to UYR if same angle subtracted from congruent angles, then the differences are congruent. Make sure it's plural there. Okay, now what do we do with those segments? Well, actually, we can just say that. Now, I'm going to say BY is congruent to UY if radii then congruent. I should really write if radii have same circle, but that's okay. Now I get triangle BYA congruent to triangle UYP, and this is going to be by SAS. And in step 6, I can say BA is congruent to UP, and that's by CPCTC. Notice how I did not say that MY is congruent to YR. Those are congruent, of course, because those are radii, but having those segments congruent doesn't help me do my proof. Excuse me, okay? So don't have extra stuff in there that you don't need. Down here is a little bit of algebra stuff. Remember, circumference is 2 pi r. Area, of course, is pi r squared. And you should be able to do these two problems yourself. Circumference ends up being 8 pi. This is 16 pi. And I'm not going to do the last one. I would like for you to do that one yourself. Of course, when I post solutions, you'll see my solutions. You get a little quadratic here, so you get a little factoring practice. But go ahead and see what you can do on this one, okay?